Let me know if you see it. Hey everybody, can everyone see me and hear me? We're good, awesome. Okay, hello everyone and welcome to another Codecademy live stream. I'm super excited to be here. My name is Patrick. I've been with Codecademy for about 7 months now. And before that, I was teaching at a web development bootcamp for the past 2 years. Super excited about today's live stream. It's a topic near and dear to my heart, gaming, video games. A lot of people get into programming for video games or vice versa. So I'm really excited to show all of you how you can make a simple web browser game, and hopefully we can build it in a way that you can expand and add your own elements and really make it your own. Thanks Meryl. To get started, I'm just going to show you what we're going to build at the very end, our sort of MVP of what we're trying to accomplish in this about half hour, 45 minutes. I've created a game called Square Adventure, and the rules of Square Adventure are relatively simple. I am a red pixel character. You can see me moving around there. And I want to move into the safe zone. And as soon as I move into the safe zone, it pops over to another area in the map. And I can see at the bottom here, I'm keeping score of how I've done so far. And that is the game we are going to be building. Cool. And I'm controlling my pixel with the keyboard. I'm using the W, A, S, and D keys. Cool. Awesome. All right. Well, I'm going to reset to a blank HTML document, and we'll get started. Pay no attention to the man behind the curtain. Cool. So just to orient ourselves with what we have on the screen, let's clear that out. Cool. I've got my index.html document. So this is your standard HTML document. I have my doc type declaration, my HTML tag, the head tag, we're not really doing much with that. And I have my body tag here, and we have a main tag. So starting with pretty much nothing, just a very, very empty skeleton of HTML. This is going to be our browser component, so anything we add into our HTML document will show up here if it's an HTML element. And then on the far right of my screen, I have my console open. You can open this if you're using Chrome with Command-Option-I. I believe you can also double-click and hit Inspect to pop it up. So what this is going to give me is all the power of JavaScript at my fingertips. I can quickly type out some code, so I can do some math here. 5 plus 7 is 12. I can do something called a console log, and that's my way of like printing to the screen, so I can say, hey, cool. And what I'm going to use this for is when I want to maybe prototype something out or test out an idea, I can pop over here and type out some code and see how it runs. So I can clear this if it gets too cluttered with Command K. So if I hold Command and K on a Mac, that will clear it out. Wonderful. All right, so now we're oriented. Today's stream is going to be based largely around an HTML element called Canvas, the Canvas element. So I'm going to add that in between our main tag. Nothing's going to go inside of it. We typically don't put things inside of Canvas, but we are going to be able to paint a whole lot of graphics inside of it. I'm also going to add an h1 tag to name our game. Does anyone have any ideas of what they want to call our game? I'll look in the chat for a suggestion. I use Square Adventure, but I'm getting kind of tired of that, so anything? I'll call it Metal Gear Square in honor of one of those classic games. I'm also going to make a section tag, and this is where I'm going to keep my score, and I'm going to make a span tag as well. Super cool game. I see Mario, so I'll add that in there as well. Great. And so just to show the other way that we're going to evaluate code here, I'm going to press this Run button at the bottom left, and we can see some changes in our browser component. So there's going to be two different ways I'm executing code, either in this console on the right or running my index.html document on the left. So we can see the changes we made to the HTML have showed up. We have Metal Gear Square, Mario, and we have our score. We can also see that there's a little bit of space between these two. And that's kind of giving us a clue to this canvas element. To be able to see the canvas element a little more clearly, because we're going to be working with it a lot, I'm going to add inside of my body a style tag. Again, this is just HTML, but inside of the style tag, I can write CSS, which is the sort of design language of the web, and it will be evaluated and applied to the HTML in the document. So I'm just doing this to give myself a little bit more of an outline of the canvas that I'm working with. So I'll give it a border of 1 pixel that's going to be solid black. And again, I'm going to click the Run button to run the code. And now I can see a nice little outline of the canvas that I'm going to be working with. Very cool. And for my next step, the majority of the work that I'm going to be doing from now onward is going to be in JavaScript. And again, just like with a style tag, I'm going to make a script tag. Again, this is HTML, but anything inside of the script tag will be evaluated as JavaScript. So just to test out that that is working, I'll put in a console log of hello there. Console log, if you're not familiar, is a way for me to print something to this console over here. So this is just sort of a sanity check for me to see whether this is being loaded properly. So I'll click run, and sure enough, I see the hello there. So looking good. Wonderful. Cool. Great. Awesome. As I said, the majority of the work we're going to be doing here is in JavaScript, but I'm going to need a reference to my canvas element. So I need to grab this HTML element, grab a reference to it, and then I can start to do the work of building my game inside that element. So instead of a console log of hello there, I'm going to use a method. I'm going to grab on the document. I'm going to query for a selector. Selector, if you're not familiar, could reference any one of these HTML tags or CSS class and so on. But for our purposes, it's enough to just say, I want the canvas element. I'm querying for the selector of canvas. And what that's going to give me is a reference to that HTML element. So I'm going to store this in a JavaScript variable. I'll declare it with the const declaration, and I'll call it canvas, canvas, and I'll set it equal to query selector canvas. Again, as a sanity check, just to make sure that I'm on the right track, I'm going to console log that element, and we'll see. I'll click over here, clear out my console, and when I run it, I should see something that gives me the impression that I'm grabbing that canvas element. So we're going to run it, and sure enough, there it is. And the kind of cool thing in Chrome is when I hover over it, you can see it highlighted over here. Great. Full disclosure, for those of you that are watching the stream and you're more familiar with JavaScript, JavaScript can be written typically with like a semicolon at the end of every expression. I am going to choose not to write semicolons just because I'm lazy and I don't want to do the typing, but I promise you that the code will execute properly. So you won't see any semicolons, sorry. Great. Back on track. So our canvas element, we can see right now by default is kind of got like a rectangular kind of shape to it. I want our game board to be just a nice square. It'll be easier to work with. So what I'm going to do is change the properties on this HTML element directly. Now that I have a reference to it, I can say canvas.width equals, let's say 300 pixels, and canvas.height equals 300 pixels. So now when I run the code, we should see this rectangle kind of square out. And we sure do. Perfect. OK, great. So now that I have a reference to my HTML element, I'm going to call a very special method on it. So as I said, this is just the HTML element on the page. But I need to get what's called a rendering context to be able to paint the pixels of the game inside of it. And the way I'm going to do that is I'm going to declare another variable. I'm going to call it context, or CTX. And I'm going to call a method on the canvas element of getContext. And getContext is a method that takes an argument of what type of context I want. And for our purposes, we're just going to have a 2D game. You can work with 3D, and there's a couple other arguments you can pass in there. But for our game, we're just going to keep it simple. Great. And again, just like before, I think this is a really good practice, especially when you're getting started. Just console log things out. just do sanity checks, make sure you're grabbing the things that you think you're grabbing. So now instead of the canvas, I'm going to console log out the context. Whoops, I want to clear this so I don't have any clutter. And when I run it, now I should see something that tells me I've instantiated this context properly. So I'm going to run that, and sure enough, I can see my canvas rendering context. Cool. So a lot of functionality here. It may feel a little overwhelming. We can open it up. We see lots of cool things here. But what this instance of a canvas rendering context is going to do is give us a lot of functionality. This is what's going to allow us to paint to the canvas and dictate where we want pixels to be displayed, how we want them to move, etc. Cool. So at this point, I'll take a quick pause for questions. If in the chat anything I've done so far is like, what, Patrick, what are you talking about? Let me know. I think Sunny said this in another live stream, but asking questions is super important. Always speak up. And I'll try to help you as best you can, or our moderators will try to help you. Oh boy. I hope that this semicolon thing isn't a distraction, because life's too short. How do you clear your console? So if you click into the console, like I'll click into it and then hold Command and then press K, it'll clear it out. And that'll be necessary to just kind of make sure it's easy to focus on the most recent thing that's popped up. Cool. All right, it seems as though everyone's on board with what we've done so far, so we're going to continue on to new and exciting things. Now that we have our context, we can start to paint into it. And this will be kind of our first magical moment of putting a pixel inside of our canvas. And I can do that on the canvas. Whoops, not in caps though. On the context, there's a method, many different methods that I can call. The first one I'm going to do is called fillRect, and that's going to paint a rectangle and fill it. FillRect takes 4 arguments. It takes the x and the y coordinate of where the rectangle starts, how wide the rectangle is, and how tall or high the rectangle is. So the coordinate plane in Canvas starts from this top left. This is 0, 0, and it goes all the way down to however large the canvas is. So in our case, because we have a 300 by 300 canvas, this bottom right pixel would be 300, 300. So I'm going to fill in these values. I'll just hard code them for now. Let's say 20, 50, and we'll make it a 50 by 50 square. Cool. So at pixel 20 from the left, pixel 50 from the top, I want to paint a 50 by 50 square. I'll run that code, and whoa, we got a pixel! Cool. We painted something into Canvas. Very, very exciting. So I've hard-coded these values, but that's not going to be very useful to me if I'm doing a game. I'm going to want to be changing these values around a lot. Like we saw, the player moves around the screen. So I'm going to store them in a variable, and I'll try to use some semantic names here. I'll say player x equals, let's start them off at 20, and player y also equals, let's just do 20. So I'm now going to swap in those variables for the hard-coded values. Cool. And it should be more or less the same. It's moved up a little bit because I changed the y value. But now we have a little more flexibility in how we're affecting our canvas. Wonderful. So one other thing is I believe our player was red, and so I can do that with the fill style property. So I set that as red, and now my pixel should be red, and it is. Wonderful. And I'm going to make my player a little bit smaller. I'm going to make him 10 by 10. Cool. So now I've got my player on the screen. So wonderful. Any questions about what we've done so far? Our first steps of using the context instance. I'm seeing a lot of sunglasses in the chat. That makes me think that everything is cool. Sweet. All right, so our next step is we want to create that base that the player is trying to move into. And so this is going to be another rectangle. So again, I'm going to use the context. This time, we noticed that that base wasn't a filled-in square. It was just an outline. So I'm going to use the stroke rect, same argument order. So it's the x, the y, the width, and the height. So let's make it, I don't know, 100, 100, 50, and 50. And now we should see another square being painted to the canvas. And sure enough, there we do. We've got our base here. So for our game, what we want is a random element to it. Like we want the player to not know where the base is going to show up until they move towards it. So we need to explore how we can bring some randomness into our game. And so I'm going to jump over to the console here and play around with it a little bit. As I said earlier, I have access to JavaScript in this console. And one of the cool things I have access to is this math object. It's got a lot of really helpful methods on it, one of which is random. So this is a method that when I invoke it, I'm going to get a number between 0 and 1 as a float or a decimal. So you can see there, it's always not quite going up to 1, not quite going down to 0. Now what I can do is use this as the basis for the coordinate. So if I take math.random and I multiply it by the dimensions of my canvas, I can get a coordinate somewhere in that plane. So I know my base is going to be 50, so I want to subtract that from the width and the height. So I will multiply random by 250, and now I'm getting a number that's somewhere in that plane. It's still a float or a decimal, and I want to floor that because I can't paint like these decimal numbers. So I'll use another math method called floor. Oh, it's getting blocked by me, sorry. All right, we'll bring this back up. Woo. Cool. So I've got math.random, and I'm going to put all of that inside of another method called toMath.floor, and that's going to floor the number. And now I get a nice round number. So this is what I'm going to use to generate a random coordinate for my base. I'm going to just copy this code straight from the console, and I'm going to put it in another variable. So this time I will, let's call it like base x equals the calculation I just made, base y also equals the calculation I just made. Great. And now I can put these into my stroke rect. So instead of hard-coded values, I'll put base x in there and base y. Cool. Now, let's clear that out. When I click run here, I should see the base in random locations. So I'll press that. Now it's in the bottom right. Click it again, a little bit over to the left, dancing all around. Sweet. I've got a randomly generated base now. I'm feeling real good. Just going to take a pause here and check out if there are any questions or anything that I've done that's really wild. My head covers the console. I apologize. I have a big head. So maybe let me just review what we've written so far, just in case anyone's gotten a little lost in the weeds. What I've done is I have my HTML right here. One of my HTML elements is my canvas. I'm using a script tag just to inject some JavaScript into my HTML document. In that JavaScript, I'm grabbing a reference to the canvas element here. I'm setting some properties to give it a proper square dimension. And then I'm creating a context with a method that's special to the canvas element called getContext. This context instance allows me to paint pixels inside of the element. So I'm declaring some coordinate variables here, and then I'm using these methods to paint inside of my canvas element. So that's where we are at this point. Can we pass color as a fifth argument? Gotcha. OK, so I'm not sure if you can pass a fifth argument to fill rect or stroke rect. I've always seen it as setting the property. I did link the documentation for Canvas if people want to check it out and experiment. It's part of the fun. Another question is, why are we setting the width and the height on the canvas element instead of using CSS? It's a little bit tricky, but our canvas element needs to actually have those dimensions, not be represented in those dimensions. CSS is something that will change the appearance of an element. It won't change the element itself. If that sounds a little bit weird, I agree. It's just sort of the way that Canvas works. If I tried to increase the canvas size just with CSS, I wouldn't be able to paint in those areas that had been expanded by the CSS. Good question. Cool. All right, so just to kind of reorient ourselves, we've got our pixel, we've got our base. We're definitely at the point now where we want to introduce some interactivity. We want to be able to press the A, W, S, or D keys and have our player move around the screen. Right now, I can press those keys and nothing happens. So when we're talking about interactivity on the web, we're talking about events. Events are, we can think of as pretty much anything a user will do in their web page. So when you're typing into an input box, that's an event. If you're clicking on a button, that's an event. If you're scrolling the screen, that's an event. In particular, for our use case, we care about the event of a key being pressed. That's what we want to capture because when we press certain keys, we want to move our player around. So to be able to listen for certain types of events, I have to call a method called addEventListener. So again, I'm going to reference the document. That's my HTML document. And I'm going to add an event listener. And the arguments for addEventListener are going to be the event that I'm listening for, and then whatever behavior I want to have execute when that event occurs. So the first thing I'm listening for is key press, and then I need to write a function to fill in that second argument. So for now, I'm going to call that function handle input. And this function is going to receive an event as an argument, so I'm going to write that in. And for now, just to get started, just to make sure, again, that sanity check, I'm going to console log the event just to make sure that things are working as they should. So now that I've written my, we call this a callback handler, I'm going to pass that in as the second argument of handle input. Great. So before I run this, just to recap, I'm adding an event listener. I'm saying, hey, make sure that you keep your ear out for any key presses. And when you do see a key press, I want you to run this function and pass in an event. Cool. So I'll click run, and nothing's happened so far because we haven't pressed any keys yet. But if I click into my browser component and then press a key, in my console here, I see I have an instance of a keyboard event being console logged out. And so that's this line of code here is what's causing us to see this keyboard event. So what is this keyboard event going to do for us? Well, it's giving us a lot of information. I'm opening it up again, and I can see it's kind of overwhelming, a lot of different properties in this instance. But one in particular that's going to be useful to me is there is a key property, and that key property refers to the key that I pressed. So just to make this a little more explicit, what I'm going to do is I have this event instance, and I'm going to use the dot notation to access a property on that instance. So I'm saying, in the event instance, give me the information under the key property. Cool. So slight tweak there. I'm going to run the code again. I'm going to do Command K to clear out my console. And now when I press keys, I just see the key that I pressed. Right? So the event object's gone, but now I know, OK, I pressed a J, an S, an H, etc. Cool. Key press a reserved word. Key press is not a reserved word, so I could declare a variable named key press, although that would be a little confusing for me. Cool. Great. So now that I have an idea of which key is being pressed, I want to sort of filter them, and I'm going to use some conditionals. I'm going to say, OK, it's great that a key was pressed, but I only want to make sure I do something for an A, W, S, or D key. So I can do that with a series of conditionals inside my function. I'm going to remove the console log for now, and I'll say, well, I'll declare a variable of like key. That's going to be event.key. So that's the key that I pressed. And then if key is equivalent to A, I want to do something. Whoa, I don't want to yell, though. Else if key is equivalent to W, I want to do something. Else if key is equivalent to a D, I want to do something. And then one last else if. If you're more familiar with JavaScript, maybe you're thinking, hey, why don't you do a switch statement, which is another way of writing these conditionals. I could have done that as well. And S is my last one. Great. And so now I can put in some console logs here, like A pressed. And then I can have W pressed. And D, oops. And let's get our alignment here all set. OK, coolio. D pressed and S pressed. OK, wonderful. So now I can run it. Let me clear out my console again. And now when I click into the browser component and press these keys, I see something. If I press other keys, you'll maybe have to take my word for it. I'm pressing other keys that aren't A, W, S, or D, and nothing's being logged. All right, wonderful. So at this point, I know I pressed these keys, but now what do I want to do with these keys? And this question is going to take us back to why do we have this pixel here at all? Like, where did this pixel come from, right? It came from this fillRect method, right? And the location specifically being 10 pixels down, 20 pixels down, 20 pixels over, came from these variables. So if I want to change the location of this pixel, I need to use this method again with different values for these variables. So let's see here. For our first key of A, if I'm pressing the A key, that's like the left key. I want my player to move to the left of the screen. I want to move in this direction. Can anyone tell me, does anyone think, like, what would I do? Which variable would I want to affect? Would I want to affect the player X or player Y variable? I'm going to want to handle the player X variable. Wonderful. Thank you, John Moore. I'm going to want to handle the X, because the X is what's handling this plane. And if specifically I'm moving towards this direction, I want to decrement or remove values, or I want to lower the value. So what I'm going to do here is take that player X variable and subtract 5 from it. Cool. And let's kind of just continue along down the line. With a W, I want to move up. So if I want to move up, what axis am I moving on? I'm going up and down in my square. So now we're doing the W key, which will move our player upwards. Y, Deadpool, TY, interwebs, you got it. And specifically, how do I want to affect my y-axis? Do I want to decrement or increment if I'm pressing the W key? If I'm pressing the W key, I want to decrement it. Wonderful. Utah by 5, got a negative y. I will accept it. And that's because, if you'll recall, the top left is 0, 0, right? So if I'm moving up in this plane, my y value is decreasing. So I'm going to subtract 5 from player y. Let's move on to D. So if I'm doing D, I'm moving to the right. And I'm going to add to the x value. And if I'm pressing S, I'm moving down. And so I'm moving down, which means I am increasing my y value. Wonderful. Cool. So I clicked the run button. I'm going to clear my console out. Click run again just for good measure. And now, if I press the key, who thinks that that pixel is going to move? Maybe just in your own mind, think to yourself, hey, is this pixel going to move or not when I press the key? I think it's really helpful when you're following along with things to try to get an idea of what do I think is going to happen. And then when you see it happen, it's the thing that you thought, and you're like, hey, I'm doing great. Move right along. If it's not the thing that you thought, then there's a disconnect in your understanding, and that's when you slow it down and say, OK, why did I think this would happen, and then that happened? So right now, if I press the key, nothing's actually going to happen. And again, this goes back to why is the pixel on the screen at all? And the reason it's on the screen is this method, this fillRect method. So I can't see the pixel move because it's not being repainted. And There's a couple different ways we can handle this. I could just take this code here, copy it, and paste it inside of my event, and that way, every time the event fired, I repaint it in that way. So I can run that, and we can see that it does a little bit of funkiness, but it does kind of move. But I actually don't want to do it like that because it's a little weird to put that type of logic inside my event handler. I'm going to introduce a new function called step. So I'll declare step. Step's not going to take any arguments. And what I really want step to do is to be like the moment-to-moment state of my game. We can almost think of it like a loop, except it's always going on. There are other activities happening while the step function is being executed. So I can take this logic of painting out my base and my player. I can put it inside my step function here. And then at the very bottom of my step function, I'm going to do something that's maybe feels a little bit funky, but it's given to us by the browser, and it's called request animation frame. This is a function that's given to us by the browser, and I'm going to pass in the function that I just wrote. So request animation frame comes from the browser. It's a function that takes a function as an argument, that function being the one I just wrote. And what it's going to do is basically say, OK, every 60th of a second or so, I'm going to run this function. And to sort of kick everything off in the beginning, outside of that function step, I'm going to again call request animation frame, just to kind of get things started. This is probably the most like, whoa, what is happening part of this live stream. But I feel like this step's pretty important because it's kind of how things continuously get painted to the screen. It is recursion, but don't worry about it. We've got some great recursion courses at Codecademy if you want to check that out in more detail. You don't really need to understand recursion for this step to work. But just to recap, I've defined my function step. I put all my painting logic inside of step. And I also told the browser, hey, just run this function like every 60th of a second. That would be super cool. Great. So I'm going to run the code. Again, nothing happens right away, but now when I press my keys, I am moving my player around. There's a little bit of weirdness here in that wherever the player was is still being painted. And that's because I haven't cleared the canvas. So essentially what I want to do is clear everything from the canvas and then repaint everything back onto the canvas. It seems like a lot of work, but computers are very fast. Request animation frame repaints so request animation frame only does whatever functionality I put inside of it. It's really just a way of saying, hey, just run this code every 60th of a second. So at the very beginning, what I want to do here is call another method on my context of clearRect. And this is my way of like wiping clean the canvas. ClearRect, just like fillRect or strokeRect, takes 4 arguments, the x and y coordinate of where I want to start clearing, and then the extent of the width and height of what I want to clear. So for our purposes, I want to clear everything. So I want to start at the top left, 0, 0, and go the whole width and height of the canvas. Cool. So I made a change of adding clearRect to the top of my step function. I'll run it again. And now when I move my player around, I don't have that trail, which was kind of cool, but not great for our game. Wonderful. OK, I'm going to take a brief pause here because we've done some crazy stuff. And I want to make sure that no one feels left behind here. So I'm just going to, again, go back over everything we've done so far. So just kind of like from the very top recap, we have an HTML document, super cool. Specifically inside of our HTML document, we have a canvas element, which is where all this magic is happening. And it's kind of cool if you think like, if we're looking at what's going on here, this is the HTML element. Like this is what you can see from the HTML element. Like we can see our h1 tag, and then this canvas is everything that's happening in here. Like really cool. I think it's really cool. I'm not just being paid to say that. And then we have our section with our score. Below that, I have a script tag, and this is my way of injecting some JavaScript into my HTML document so I can do some of the functionality and interactivity of our game. And within my JavaScript tag, I'm grabbing a reference to that canvas element. I'm setting some properties on it. I'm getting a rendering context from the element. This is what's going to allow me access to all those different methods that paint the pixels onto the canvas. I'm declaring some variables to give me an idea of where my player and my base will be in the canvas. I have a step function, which is my, like, sort of every beat, every moment of my game, I want this to happen. And I'm starting that loop or that recursive exchange right here. I have what's called an event handler called handle input. This is what is happening every time there is a key press event, because I added an event listener. I'm looking for key presses, and whenever those key presses happen, I want to run this function. And in the function, I'm going to be looking at the event and saying, hey, was the key an A, a W, etc. And that's where we're at. Oh my gosh, Deadpool TY Interwebs, you're the best. Cool. If the frames aren't rendered equally fast, how do you move the player at a constant rate? So that's a good question. This is a little bit more advanced step. Request animation frame does have some fine tuning in it. For our purposes today, we're not really going to mess with it too much. But maybe to really like drive home how often this is happening, I'm going to do something just as a little experiment to illustrate it. I'm going to take that player x value, and again, this is what's dictating where on the x-axis my player is showing up. And in my step function, I'm going to increment it by 1. So every 60th of a second, my player x is going to be incremented by 1 and then painted to the canvas. And this should be pretty cool, I guess. I don't know. Who knows? Well, look at him go. Hey! So you can see, like, this is happening every 60th of a second. My player is running off the screen. I don't actually want to do that, right? I want to be able to control how my player moves. But that's kind of how we get some animation going on. It's a little sneak peek. So good question about the arrow keys instead of letter keys. The reason why I chose the letter keys is sometimes people don't have arrow keys on their keyboard. And also, there's a little bit of weirdness with the key press event where it won't actually register an arrow key. So I didn't want to go down that rabbit hole. Not worth pointing out. But AWSD are kind of a classic, like, moving around. Great. OK, cool. So enough jibber jabber. We have some interactivity in our game. What I'm looking for now is sort of like the final cherry on the sundae. I want to be able to sort of like have something happen. When my player moves into the base, like that, I want the base to go to a different location. I want like it to magically reappear somewhere else. Princess is in another castle, that kind of an idea, right? So this is going to touch on a essential part of writing games. It's a super, super, super important concept, so I'm going to kind of belabor it a lot. We want to take a step back and ask ourselves, what does it mean for our player, our x dot, to be inside of this square? And when we're dealing with canvas, we're just dealing with pixels. We just know x, y coordinates on a plane. So to be inside of the square means my x coordinate is greater than or equal to this other thing's x coordinate. Like right now, I've got an x coordinate that's a little bit less than the base, and now my x coordinate is greater than the base. And similarly, by the y coordinate perspective, right now I have a lesser than y coordinate, and now I've got a greater than y coordinate. So that's how we're going to evaluate whether our player has moved inside of the base. And this logic is something that I want to be checking for all the time. And so this is a good candidate to put inside of our step function. So I'm going to use a conditional and say, if my player x, my x coordinate, is greater than or equal to my, what did I call it, base x, then I know I've collided. There are a couple others that I want to do here. If my player, ooh, whoopsie. If my player y is greater than or equal to my base y, then I know I've gone past it. So this is sort of my console.log, you won or you scored, something like that, right? I don't want to take too many steps at once. And, all right. So we'll just kind of see how this runs. I'll run the code. And now inside of my step function, I'm always checking, like, have I gone into the base? Have I gone into the base? So I will move over. And we can see right now, I haven't gone in the base. I haven't gone in the base. And if we keep our eyes over here, whoa, I have really gone in the base. The reason why there's this number here is the step function is, again, running every 60th of a second, so it's running a lot. That just means that U1 has been console logged multiple times, in this case, 700 times. Cool. So I'm going to clear the console one more time, and I just kind of want to illustrate a bug that I kind of put intentionally in here. One thing I didn't think about is, what if I am not in the base right now, but I move down, and oh no, I'm winning, but I'm not really winning, if you know what I mean. And so what I haven't thought about here is there's an extent of like where the base is. And that's going to be the start point of the base coordinate and then how wide it is. So I need to add to my conditional here. And let's see if I can do this. My player x needs to be less than or equal to the base x plus the width of the base. And the width of the base is 50. Cool. And then I want to do the same thing with my y coordinates. So player y has got to be less than or equal to the base y plus 50. OK, cool. This is not going to be like the most precise coordinates ever, and that's OK. We don't want to get bogged too down in the details. But just to recap here, I want to make sure that when I'm not really winning, my game isn't throwing a bug there. So now if I'm going down, we can see that my coordinate is greater than, but still within the bound. So I'm not, it looks like I fixed this problem. Cool, I'm circling around the base. Oh, when is it going to happen? Oh, I won! Hooray. Cool. Awesome. And so at this point, yep, I have kind of a functioning game. What I've done right now is collision detection. And the reason why I'm making such a big deal about it is it boils down to, in your game, when do you want to know when something contacts something else? So think of it like, when we want to know when Mario hits a mushroom. We want to know when Mario is on top of a Koopa. We want to know when Sonic has touched a ring. We want to know when Pac-Man has eaten one of those little golden things. I don't know what the word for it is. But knowing when something has collided with or contacted something else is like so essential in game development, right? It's like you have to know that. It's what so many games are built on. And ultimately, this is what it comes down to. It's just XY coordinates in a 2D game. So it's pretty cool. Nice. I'll just take a break now. Oh, wow, we've gone like almost 45 minutes. That's wild. Time flies when you're having fun. Let's wrap this up really, really quick. The one last thing I want to do is like make this random base generation. So pretty easy, or not, I shouldn't say that. But the way that we built it out so far, small tweak. I just need to reset my base x and my base y. So this if conditional is kind of like, if I won, then I want to make a new base location. So I'll just copy that code of a random coordinate. And now my step function will place the base somewhere else if I ever contact it. And let's go for it. Let's see if this works. All right, really making me work for it. Ooh, you scamp. And there we go. OK, cool, dancing around. Awesome. OK, so we didn't quite get to everything, but I thought we'd pretty much have an MVP, a minimum viable product for our game. I had a lot of fun. I really, we could definitely play sounds, like pretty much whatever logic we want to have happen when we like win or enter a base, we could do right in there. So the sky's the limit. You're only bounded by your own imagination. Very cool stuff. Yeah, so to recap, I guess one last time I'll run through everything, just at the sort of danger of being a little verbose here. We've got our HTML document. We have our canvas element inside of our document. That's where all the magic is happening. I made a script tag so I can run some JavaScript in my HTML. I'm grabbing a reference to that HTML element. I'm setting the properties to give it a nice dimension. I'm getting a context instance, and this is very important because this is how I'm able to paint all the different pixels into the canvas. I'm getting some XY coordinates for my base and my player. I have a step function which is going to run every 60th of a second, and every 60th of a second it's going to clear out the context, set a color, draw the base and the player, or the player and the base, check if the player has one. If the player has one, it's going to move the base to a different location, and then it's just going to recursively keep calling itself. It's just going to keep running this loop. My other function is my handle input, and this is the function I wrote to check what key I'm pressing. And depending on the key I'm pressing, I'm going to change these variables which dictate where on the canvas the player is. So this is how I'm moving the player around the canvas. And last but not least, I'm adding an event listener and saying, hey, I want to make sure that whenever there's a key press, you run this function. And that pretty much takes us to the end of the stream. I just want to say, again, I really appreciate everyone's attention. Super exciting stuff. To give you some ideas of how you can change this, let's say that every time my player moves into the base gets a little bit smaller. So I want my base to get harder to get into. Well, to do that, what I could do is create another variable for my base's dimensions, which I have right here. And then I could decrement those dimensions every time I won. Another idea would be to set up a timer. And so maybe there's like a 5-second countdown. So if my player doesn't arrive in the base in 5 seconds, then I lose the game. Some other things that I could do are maybe there are some randomly generated power-ups. Like I could randomly put another square that's blue, and if my player enters blue, it can move twice as fast. Twice as fast means that instead of incrementing or decrementing by 5, maybe I'm incrementing or decrementing by 10 pixels. So the way that I would kind of phrase it is, what do I want to have happen in my game? What is making that happen in the game right now, and how can I alter that? Usually you're going to be storing it in a variable, changing that variable around. I would also say, this is an example that kind of intentionally avoids using JavaScript classes. And that's because I wanted to keep this as approachable as possible. But it's definitely a good idea if you do feel comfortable with JavaScript classes. And again, we have some really great Codecademy courses on them. Sort of packaging up the functionality of like, I could have a player class and I could have a base class. And then any specific functionality would live in that class, and it would keep things a little bit tidier than the way I have it right now. Cool. All right, I guess that's it. I don't know. What am I? Oh yeah, if you want to leave feedback, if you're interested in this type of material, I know that there has been some, but please let us know. We would love to build a course on game design, something like this. Let us know. We're always looking to improve and do better by our learners. So yeah, fill out the feedback form. Thanks everyone, and go make some games.